Okay, what are you going to do on those cloudy nights? Well, what I've got here is one of these Arduino microcontrollers, the UNO board. It's a very interesting project. What I'm going to do is I'm going to use this controller to create a virtual USB port to enable me to focus the Mewlon by turning on the outputs to drive the motorized secondary focuser. Now what you've got here is the output of the Arduino, pin number 5, is being taken to this component here. Now this is a N-channel MOSFET field effect transistor. The reason I've used this is this board can drive around about 20 milliamps output. It's not much current if you want to do any useful work with this. You want to drive a relay or motors or whatever else. So hence what I've done is I've used this N-channel MOSFET here, and the reason I've used this instead of a transistor or any other solution is basically all I need to do is to give the gate of this MOSFET a logic signal. So the 5 volts 20 milliamps from the Arduino is perfect, and then I can actually supply a separate source to the drain and source of this MOSFET to drive anything up to 100 volts DC and 1 or 2 amps. So that's why this component becomes very interesting to use. So now I can put small motors, relays, anything I really want to onto this N-channel MOSFET device. Now I'll show you the programming I've done. I'm a big fan of Python. So here now you can see a Python program which I've written to provide a small interface to be able to drive the. Now if I simply run this, run module, you see I get this interface here. So this lists the serial ports on my Mac and allows me to connect to the serial port. Connect. So here now you can see that I'm connected to the serial port. Here's the Arduino sketch. Basically the sketch here is just listening to the commands from the dialog box here. Essentially I'm sending focuser in, focuser out, and this then should respond by writing the pin of the Arduino high for desired length of time. What I've not done yet is I've not implemented this delay. I decided to put a delay in milliseconds, so 300, 400 or half a second or 1 second. That means that when you hit the focus in button, the Arduino sketch will run the motor for 1 second or for half a second or less, depending on what delay you set. Now let's see if it works. So I'll come back down to the board. So now you're just going to have to trust me. If I hit the focuser out, there you go. The LED flashes on, driving this N-channel MOSFET device, which I can then put another power supply on. What I've also developed for the Arduino is my own motor shield. Essentially I've put some headers onto a piece of prototype board. This then plugs on top of the Arduino, and what I plan to do is to transfer this circuit onto the top of here. I have a 4AA battery pack which will be used as a separate power supply. Remember, for the source and drain you could use up to 12 volts or 100 volts DC, whatever you want to use, depends what you're driving. So this separate battery pack will be used to drive the Mewlon via this project board once it's mounted on top here of the Arduino. Once it's all complete, I'll come back and show you all. Okay, so here now is the final solution. Again, a little bit echo from my Mewlon tube. So what I've finally done, the MOSFETs pull the relay coils which provides the positives to the Mewlon Focuser. Effectively this is acting, it's very similar to the buttons here. Let me show you now. Click. You can hear the telescope focuser moving. 1.5 seconds. Go to the screen. See the program is running. So focus in and focus out. It's a little bit dark, but you can see the focuser moving the motor. So everything is now working perfectly as planned.